Section 2.1a is about graphing rational numbers. Before we can talk about what rational numbers, we have to talk about what a whole bunch of other numbers are that make up the rational numbers. We're going to start with the natural numbers. Here we have a set that represents the natural numbers. It's a set because it has squiggly brackets, and each element in the set is separated by commas. Now the natural numbers are the numbers that start with 1, then go to 2, 3, and these three dots here mean that the pattern goes on forever. So 4, 5, 6, 7, often to infinity. Those are the natural numbers. The next set of numbers are the whole numbers. The whole numbers are identical to the natural numbers except they include a 0. And the way that I remember whole numbers is the word whole has an O in it, and so the whole numbers has to include 0, whereas the rest of the numbers are the same as the natural numbers. The next group are called the integers. The integers can be described as the positive and the negative whole numbers because it's the same as the whole numbers to the right, but it also has those same numbers in the negative direction. Notice it goes on forever negative and goes on forever positive. Positive numbers are nothing more than the positive portion of the integers. So these numbers would be considered positive, and then these numbers on this side of the integers would be considered the negative numbers. Most people know what those are. Notice that 0 is neither positive nor negative. It's a number unto itself. And that finally brings us to the rational numbers. Rational numbers are numbers that can be written in the form a over b. In other words, they can be written as a fraction. All of these numbers up here are considered rational, as well as any fraction that you can think of. 2 is rational because it can be written as 2 over 1. 4/3 is rational. 0.3 repeating is rational because that's the same as 1/3, so you can write that decimal as a fraction, so therefore it's a rational number. -12 is rational. Pretty much any number that you can think of that's written as a fraction, that can be written as a fraction, is considered a rational number. Here we're going to learn to graph on a number line. The definition of the word graph in this sense is to draw or plot a point named by a number on a number line. You might be thinking of graphing in an XY plane. Perhaps you've learned that before, but here we're just talking about graphing on a number line. The word coordinate is what we use to describe the number that corresponds to a point. So as you come down here, you see a number line with a bunch of coordinates on it, and there's also some dots. What we have to do is we have to name the coordinates of these points that are graphed on the number line. The way you do that is you make a squiggly bracket to show this is a set, and you list all the numbers that have blue dots on them. In this case, -4, -3, -2, 1, and 2. That's naming the coordinates. Let's do the next one, letter B. 1, 1.5, 2, 2.5, and 3. Now I'm not done because you see this arrow here? That dark blue arrow shows us that the pattern continues forever. This dark blue arrow is the same, if you remember, the 3 dots that we did in the last slide. That meant the pattern continues forever. That's called an ellipsis, and this arrow means the same thing as the ellipsis. It means the pattern continues forever. So the way that we write that in our set is by putting the 3 dots. The arrow and the 3 dots mean the same thing, except one of them is on the number line, the other one is part of a set. Here's some more examples of naming coordinates that are already graphed on a line. There's the first one and the second one. Notice the pattern continues to the left, so I use my ellipsis for that. Here we have a couple examples where we're actually given the set of numbers and we have to provide the graph. So we're going to work in reverse from what we've already done. I'm going to start with -4. Now I'm going to use the same color system that we've been using up to this point. I use blue dots to represent each one of my numbers. So here's what all my numbers would look like graphed on a number line. The one thing that I haven't included yet is the ellipsis on the left, which means the pattern continues to the left. So I will make a dark arrow showing that the pattern continues to the left. This next example is interesting because it's by thirds. Whenever you have a graph or a set of numbers that's in fractional form, the best way to do that is to divide your graph into groups of 3. So I'm going to start here by doing -2, which is really -6/3. And then I'm going to go -1, which is really -3/3. And notice I've divided that interval up into threes. And then here's 0, divided into threes. Here's 1, which is 3/3. I'm writing it as a fraction because that'll allow me to put my fractions on here. And then here's 2, which is really the fraction 6/3. And that's really all I need. The pattern will go on forever. So now I'm going to put my dots on. -4/3, well, here's -3/3. -4/3 goes here. -1/3 is here. 2/3 is smaller than 1, and then 5/3. There is no pattern that goes on forever, so I'm done. Here we're told to graph a set of numbers, but we're not given a set with numbers, we're actually given a set with words. So let's see how to do this. It says integers less than -3 or greater than or equal to 5. Well, if you remember what the integers are, they're the positive and the negative whole numbers. So here's a reminder of what the integers look like. If you notice, there are no fractions, there are no decimals. Integers are just the numbers 1, 2, 3, and then -1, 2, 3 off into infinity. So we're not talking about anything in between those numbers, no fractions or decimals. So I want to find the integers that are less than -3. Well, let's start with 0. Here's -3. So the first integer that's smaller than -3 would be -4. And that means -5 would go, so would -6. And that goes on forever. Well, the way we write that is we show a dark arrow that goes on forever, and then we show what the pattern looks like. -4, -5, -6, and then to infinity. And then the other side of it says greater than or equal to 5. So here's 3, 4, 5. I'm going to start at 5 this time because we actually can equal 5. So I'm going to use blue dots to show 5, 6, and 7, and that's enough to show that the pattern will continue by ones off to infinity. So notice the difference from the left side and the right side. It says less than -3, so we didn't include -3 in our graph. But over here, because it was greater than or equal to 5, we included it. Only dots are graphed, and then this says the pattern continues to the right and to the left. There is no shading in between those dots because we're not talking about decimals and fractions, because it says to only graph integers.